This is a puzzle called Broken Fence by Myxo. I got it from the Sudoku testing submissions channel on the Discord. Let's take a look at the rules. So the first one is killer cages. So the digits inside of a cage add up to whatever's there. Looks like they always add up to 28 in this puzzle, so that's nice. But yeah, so yeah, these digits, whatever they are, add up to 28. Um, Yeah, typically digits can't repeat within a cage, but that doesn't matter for this puzzle. Okay, because they're always in the same box, I mean. So thermometer rules, yep. So if we determine, like this is a thermometer, this gray line here. If we somehow determine that this is a 4, then this digit must be a 1, 2, or 3 because it is closer to the bulb, the circle on the line. And this digit, because it's farther away from the bulb than the 4, must be greater. So digits increase as you move away from the bulb. They don't have to increase by 1. It could be any amount of increase. So this could be an 8. That would be valid. This could be a 2 or 3 or whatever. Whoops. Let's delete that. Diagonal. Okay, so we have a long diagonal here. And this is going to have the digits 1 through 9 without any repeats. Okay, and then little killer. Right here, these digits will add up to 27. And digits can repeat on this line. So, like this could be a 6, and then we could also have a 6 here, for example. I think that's all of the rules, all of the things we need to go over. I'll put a link to the puzzle down in the description if you want to try it for yourself. I don't know how difficult this is. There are a lot of clues, it looks like, but at the same time, these clues aren't super restrictive. Like a 2-cell thermo says very little, gives very little information. So I don't know. It's hard to tell, and I don't really know this, or I don't know this solver at all. So I don't know if, or this setter, I mean. So I don't know if they even generally make hard puzzles or easy puzzles. So unfortunately, I really have zero clue how hard this puzzle is, or if I'll even be able to finish it. But if I finish it, which means someone's listening to this, I guess. I must have finished it. Judged by the length of the video, probably. See if you want to give it a try. Let's just hop right into it. Where to start? I think the place to start... Let's color this line again. The little killer. I don't think it'll be helpful for the next probably half an hour of the solve. But might be nice. Okay, I did just have one idea, but actually it's gonna mean I'm gonna have to undo that. Yeah, but let's look at these thermos first. So this is that's all the way up to 6. That's really not helpful. Although this can't be a 6. I don't think it's gonna be helpful enough to do it that way. So this is, yeah, this thermo is gonna be restricted. Without the killer cage here, we could theoretically put all the way up to 6 in this box because it could be 6, 7, whoops, 6, 7, 8, 9. But that's already too large for this 28 gauge. And 6 forces this 7, 8, 9 this way, so it couldn't be a 6. And even if this was 5, this could be 6, 7, 8, which is 21, 26, so this could be a 2 then. Okay, so maybe it could even be a 5. Okay, well that's really not very restricted at all. I was thinking we would get a little bit more use out of the killer cage there. But yeah, like I said, the 28 in a killer cage is so many options. Okay, the other thing I noticed, and I don't know exactly how it'll work, but maybe something to do with set theory. I don't know if set theory is the right term for this actually, because I do see something, but let's look at it this way. So this is 3 sets of the digits 1 to 9. Whoops, let's actually highlight correctly. And this is 3 sets of the digits 1 to 9. Let me actually get a calculator up while I'm thinking about this. So the highlighted cells here are 28 times 9. They sum up to 28 times 9 because they fully fill all 9 killer cages. Yeah. But they also have um, 6 sets of the digits 1 to 9, almost. So that would be minus 6 times 45. But these cells are double counted. So we have 28 times 9, and we subtract off 6 sets of the digits 1 to 9, which is going to add up to 45. And we're left over with what these digits sum to, which is negative 18. Oh, I guess I did the subtraction the wrong way. It should have been the bigger digit first. But in any case, these digits add up to 18, and that's the way we break into this. Yeah. So this must be 1, 2, 3. That's the only way to do it. Because in a row, the lowest you can do is 1, 2, 3, which will be 6, and 6 times 3 is 18. Yeah, I think that is right. Now this color is going to be very annoying, so let's get rid of that. Very Christmas themed puzzle, but if I colored it that way, but also very annoying. So these ones can't be 1. Sorry, yeah, can't be 1 because they're in the midpoint on a thermo. Ones can only appear at the beginning. So the start of these can be 1 or 2. Well, we do have a 1, 2, 3 triple along this line, for whatever that's worth. Little killer is not going to be helpful. This is going to be pretty restricted here. I don't know if that's where I want to, if that's really even helpful. Apologies if you can hear my chair. It is a squeaky chair, and my mic is not great. I try to sit still, but that's not always possible. Um, hmm. Yeah, this little killer clue, it's just the 4 digits, but I can't. There we go. Oh, almost. Yeah, that's not helpful yet. If we were trying to minimize the little killer clue, then these would be very helpful, but we're not minimized. It's going to be, well, not maximized, but pretty large digits across there. Yeah, so these are minimum of, these could be, whoops, 4, 5, 6, 7, 8. That's not helpful. This could be 8 and then 9 over there. Yeah, that's not very helpful. Okay, so maybe I do need to look at these thermos. This is 2 through 7. Yeah, that's a lot of options there. Oh, it can't be 1, 2, or 3 because we have, well, this can't be 1, 2, or 3 actually. Oh, that's, okay. I'm much less angry about, not angry. I'm much less worried about this thermo, than I was a few seconds ago. Yeah, dealing with all the different options that were possible when this was 1 through 5 would have been a little tedious, but I don't have to do that, so it's not tedious. Let's see if this is, as I said, yeah, I did this before. If this is 5, and if I do minimums all the way around, actually, let's look at this. If this is 7, then this has to be 8, this has to be 9, then this is 24, and we can't, like, and just adding this digit, this is 28 already before I even get to the middle digit. So this can't be a 7. What if this is an 8? This is a 9. And then we minimize this and minimize this. That's 9 plus 9 is 18. That'd be 26. Did I not do that? Oh, that'd be 26. That would be a 2, right? 26 plus what equals 28? That's the advanced math that I'm struggling with today. So if this is a 2, all of these are 3s. Which makes both of these 1s, and both of these 2s, and makes that a 1. Is that a problem? I don't see it as a problem, but... Okay, how could this... I guess if this was not an 8, if this was lower... What if this was a 7? If the final digit was a 7, then this would be 7654, which is 10, 15, 22, and this can't be high enough. So this can't be a 7. What if this was a 6? If this is a 6, this is again 5 and 4, but we could up this now to 9. And this is not high enough. This is 15, 20, 24, and then at most 3, which will only be 27. So we can get rid of this. This can't be a 6 any longer. And I think this is going to be symmetrical up here, because it looks like the exact same thing. So I'm just going to type that in. 5, 6, 7, 8, 8, 9. So a thought comes to mind, and that is... Well, I have a couple thoughts. If we can force a digit to be on this thermometer and this thermometer, then it won't be on the line here or here. So if, like, let's say this has to be a 5 for whatever reason, or if we determine this is a 5 or this is a 5 always, and the same thing is true here. I'm not saying that's the case, I'm just saying if we could prove that somehow, then 5 on the diagonal would not be here, here, and we would have to have a 5 in here. Which is interesting, but I don't know. I think it's good to keep that in mind, but I don't have any way of making use of that. The other thing I just realized as I was thinking about that, 9 can't be on this middle box. So 9 is here, or here, or here, or here. So there's a 9 in one of these, which is going to force this to be 8, 7. So let's just see what that math looks like. One of these, let's just assume it's down here. It doesn't matter really which one it is. It's symmetric. So if this is 8, this is 7, and we'll just assume 9 is in here. This is 15. So we need this to be 13, which has a couple different options. This couldn't be a 5 then. This would have to be a... because if this was 5, this would be 4, and then we couldn't reach up to 14. Or, sorry, up to 13. Wait, yeah, up to 13, because that would require another 4. 5, 4, and then another 4. So this has to be a 6. Then this adds up to... This is 21, so this has to add up to 7, so this couldn't be a 1. Okay, so that's going to force a 1 onto the opposite side. And what is the 1 going to do? So that means this has to add up to 27, which wasn't that like the maximum? Maybe not. 5, 6. I don't remember how that went offhand. But yeah, these digits, whatever these digits are, must show up actually in these 4 spots specific. Oh my gosh, I didn't realize. That's interesting. Now that's really interesting. So these 4 digits, let's use dark green, I suppose. On this line, they can't show up, obviously, the green digits are not 1, 2, or 3, so they're not there. So those green digits are exactly in these spots. And I don't know, this is not correct with the 9. This is just like one example. It could be flipped all the way around. And this, actually, and let's just do that for the moment. So dark green is there, and then we can do dark pink, I suppose, is here. And so that thing I was thinking about is actually definitely the case. Yeah, it's definitely the case. There have to be 2 repeated digits on the thermos. Okay, and it's not 9. Because 9 can't appear in the middle. So one of these is 9. Let's say it's, whoops, let's say it's down here. We'll go through this logic again. This must be 8. This must be, whoops, must be 7. This must be 6. That's 21. So this has to add to 7, so this can't be a 1. That makes this a 1. Which I think then forces this to be a 9? Because, oh, you know what? Let's skip back. I just saw something else. Where do 1, 2, and 3 go in this box and this box? 1, 2, and 3 are not dark green, and they're not on the thermo. And similarly, they're not dark pink, and they're not on the thermo. Because we already have a 1, 2, 3 here, so these two can't be 1, 2, and 3. This can't be 1, 2, and 3 because of the 1 in the row, so that rules 1, 2, 3 out of the whole thermo. Yeah, sorry, just had to go through all that logic again because that seemed like a big step. But yeah, 1, 2, 3 is there. That doesn't quite get us any more information. Like we have another set of the digits, kind of looks like it's prepping to maybe be in the top left, but not quite ready yet. Okay, so back to here. One of these will have 9, and then the other side will have a 9 on the arrow. So if the 9 is done, but I guess if it's symmetrical, how? I guess we could find out what the repeated digits are. That's what we're looking for right now. We won't be able to find out which side is which. Like which side is the side with the 9 on the diagonal. But we will be able to find out, hopefully, what these repeated digits are. So on this side, we need a 9 on the line. And this must be the 1. So we have 10, so this has to add up to 8. Whoops, this has to add up to 18. If this is an 8, this must be 4, 6. If this is a 7, this has 5, 6. So this is 6 no matter what. Let's think about that again. We have 28 total. We have 10 so far. So these 3 digits have to add up to 18. Yeah, that math seems to check out in my head. So if this is a 7, these two have to add up to 11, which must be 5, 6. If this is an 8, these two have to add up to 10, which must be 4, 6. So no matter what, this is a 6. Okay, so 6 is one of the repeated digits. That's good to know. So now we have 16, these have to add to 12, but unfortunately either way works. Either way works. So this 6 is one of these. Okay, so if 18 is in the cage, or sorry, if 28 is in the cage, then 17 is out of the cage. If we have a 6 and a 2, let's just assume this is 2, we'll maximize it. Then that's 8. So the other 2 digits have to add up to 9 or 10. Hmm. So let me think for a moment. this digit actually must be, no, but yeah, this is weird because this digit could be a 3, but it can't be, it has to be a fairly higher digit, I guess. But the other repeated digit, I guess, could be as low as a 4. If this is a 4, no, 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 no. This 7, 8 is the repeated digit. This has a 7 and an 8, and this will have one of them. So this is, let's just remove that for a second. This is 6, 7, 8. Yeah, that's definitely true. I should have caught that. And these 4 5s are opposites of each other. Yeah, that's true as well. So this is 6, 7, 8. Again, this thermo and this thermo, or this whole box basically, and this whole box could be swapped. We don't know which side is which, but for right now we're just trying to focus on the middle box and see what we can come up with there. So this is 6, 7, 8 are repeated. Well, a 6 and a 7 or an 8, I should say. And we need to add this up to 17. So if this is 6, 7, 1, this would have to be a 4. So this is a 4 at maximum. Right? If we minimize this is 6, 7 will be 13, plus 1 is 14. So maximum is 4. Minimum would be 6, 8, 2, which would be 16, which would require, oh, wait a minute, that's a 1. Why is that? Am I doing the math wrong? This is 28, so this is 17. So if this is 6, 7, and 1, yeah, this can't be a 4. If this is 6, 7, that's 13, plus 1 is 14, which would make this a 3. That must be true. That must be the case, because we can't, 3 is the absolute minimum for this. Okay, so we just had a good, good breakthrough here. So this can't be an 8. If there's an 8 on this line, this is going to be pushed smaller, and this is already the minimum digit it can be. So let's clean this up a little bit. These digits are wrong. This is an 8 or a 9. This is a 7 or an 8. This is a 5 or a 6. 5 or a 6. 8 or a 9. 1, 2, or a 3. This could have a 1. 9 is not restricted there. Okay, but this is a 3. This is a 2. This is a 1. Oh, and those 2. And then we have a 1, 3 pair there, and there. Oh, wow. Okay, so this can't be a 1. This can't be a 1. I think that's good. Okay. These must be 7, 8, 9. I don't know how helpful that will be right away. Okay, so 6 is repeated, so these are always 6. I guess I could have written that in. Oh, this is 8, 9, not 7, 8. And then 7s are repeated. And this is the only spot for a 7, so these both must be 7. So we have 4, 5, 8, 9 up here, or along here. So this is either both minimums, so this is 13, so these have to add up to 15. So if we do both minimums, then we can do a 3 here. So 8, 4, 3, or 9, 5, 1. Yeah. Okay. Do I need the colors anymore? Maybe a little bit, because if I figure out this is a 5, let's say, I do want to immediately know that this must be a 5. This must be 4, 5, 8, 9. I guess we know these two digits aren't both the same, because that would break the middle box. If this was like both nines, let's say, then 9 would be ruled out from the cage and it must include a 9. Okay, let's see. 27. This doesn't really restrict it very much. I was thinking it might do a little bit. Like, this can't be a 7, but that's not that, that's not that big of a deal. And I guess no 6s in the middle box, or in box 1, middle digits on the line. That doesn't really matter. This could be anything greater than a 3. Does this have to be a 3? Let's see, these can't be 3s, these can't be 3s. So 3 is in one of these corners. Is there a reason why this can't be a 3? Oh, this can't be a 7, I'm just noticing that. Because obviously there's a 7 right there looking at it. Does that mean that doesn't mean this has to be a 7, because of course it could be like 6-8 or something like that. Oh, okay, here's the next step. 6 is now looking at box 1. So 6 is forced out of the box as well. And again, it has to add up to 17. So we have a 3, a 6, a 1, and then a 7? Is that the right math? 1 plus 3 plus 6 is 10. And then we need a 7 more to be 17, yeah. So this is a 3, 6 right here, and we have a 7 right here, which puts a 7 onto the line. And remove 7 as an option there. And put 7... Did I say 7 onto the line? I meant onto the, into the cage. Can we do that down here? No. The 6s are offset, unfortunately. Oh, but we can do it over here. So we have, I don't know, sort of an X-wing on 7s here. So where can 7 go in row 7? Sorry, 7's on the brain. Where can 7 go in row 5? It can't go in box 4 because we just said it must be here or here. It can't go here because none of those are 7s. And obviously it can't go on top of a digit we just placed, so one of those is a 7. And similarly, we can ask the same question about column 5. 7 can't be there. 7 can't be there because none of those can be 7. And so 7 is down there. Oh! 7s in box 9 are out here. They work basically the same way as 6s did. But down here, I guess. And I think 3s are going to act the same way. Yeah, they are. This 1-3 pair and this 1-3 pair are going to force the 3s out of the box. So we have 1, 3, and 7, which is going to require the 6. And the 6 is going to place that over there. So this is 3, 7. I guess I could have removed this as an option, removed 3 as an option there from this pair, but I did not catch that. But I did notice it here, so that's good. These looking down, I don't see anything. So this can't be a 7 any longer, so this must be a 7. What does that mean? Does that mean anything? I think it just means that that's a 7. That's fine. Not every digit you get is gonna break open the puzzle. Okay, what's left in this box is 4, 5, 8, 9 again. Is that right? 4, 5 is 9, plus 9 is 18, plus 8 is 26, plus 2 is 28. Yeah, that is correct. I don't know if this is helpful. So this 4, 5, we talked about this before. I guess we don't, that doesn't matter. This 4-5, where does this 4-5, and I'll call this yellow. Where does yellow go in this killer cage? It must go up in one of these spots, which does again prove that these two digits are different because otherwise they would see each other. And this cell up here, this 4-5 up here, similarly is looking this way. So neither of these digits can be 4-5. So this is what? An 8, 9. Can't have 4 or 5. What digits am I forgetting here? What is going on? Oh, a 6. Of course, there's a 6 right here and a 6 right here. So this has a 6, and then it has an 8 or a 9. Okay. Okay. Okay, so a similar thing I'm just noticing. Let's get rid... Oh, my power just flickered. That shouldn't matter, I'm on a laptop. But that was weird. I don't know why my power is flickering. Okay. The same thing can be done for 8 and 9. And I actually kind of mentioned this, but then didn't, come to any conclusions about it. Whoops. So if green and pink were the same digit, if they were both 9 or both 8, then that digit would be ruled out from box 5. So these must be different digits. So green is in one of these because it can't be in these because of this, obviously. And we can do the same thing for pink. Now we come over here. This can't be 1, 2, or 3 because of this triple. So it could be 4, 5, I think. But can't be 6, can't be 7, and now it can't be 8 or 9 because of the coloring here. So this is just 4, 5. Which I think gives us a 6 in the row. Yeah, I guess there's two different ways we can think about this. This is a quadruple. That's one way of thinking about it. The other way, which was the first way I thought of it, was this has an 8 or a 9, so the other digit is a 4 or a 5. That 4 or 5 pairs up with this 4 or 5, so we've used the 4 or 5 in the row, but this must be a 6, which means this was a 3, this is a 6. So this 3 looks down here, and unfortunately does not help as much as I wanted it to. I thought we were going to get all 3 of these digits. Let's see. I would like to be able to figure out which 4, 5 that is. But I don't see how to do that. I guess I can color yellow up here, and I can color purple down here. I don't know how helpful that is. That might just be adding clutter to the board effectively. I think we're going to be able to do something similar in this column, either now or very soon. But I'm not sure. Let me just check over here. 4, 5, 4, 5, 8, 9. Yeah, we have 4 spots and 4 digits left. Okay, let's look at this. So these two digits can't be 4 and 5. So there's 6, 8, 9. Maybe I should be working on the math part of this actually. I think this is good. I think we're going to get another 6 up here. So what's left? These can't be 1, 2, or 3 because of this triple. They can be 4, 5. They can't be 6. We just put that here. It could be 7, but then it can't be 8, 9 because of this kind of virtual pair here. And now we have a quintuple here, 4, 5, 7, 8, 9, which means this must be 6. Which, yeah, we could have gotten that a different way too. We had the 6s out here, so that was the only place in the column that 6 could go. But as long as you get the right answer, this doesn't matter what logic you use. even if it's slightly harder, slightly harder logic. Let's look at the math of this. So this is 7 and 6. So this is 13, so this has to add up to 15, and this can't be a 6, because we're using the 6 up here. I mean, and obviously that could be switched around, but this is just the way I'm thinking about it. So this is, I don't want to type that in because I feel like I'm going to make a mistake if I do that. So this is 15. If this is a 9, this could be 915. If it's an 8, it could be 834. Ooh, both of those options work. That wasn't what I was expecting. I was expecting one of them to work. Unfortunately. Yeah, unfortunately it uses all the possible digits there. So it can't even like rule out an option. That's annoying. Okay, here's something I can do. I don't know if this is helpful. I'm just going to say that as I do it. So we colored the different ones and what am I trying to say? Ones and threes. So this configuration here, this is also going to have a 6 and 7. We just don't know where the 7 is. But it's going to have a 6 and a 7. And its configuration is going to be the opposite of this configuration. Because it has the opposite of 1 or 3, of the 1-3 pair. But what does that mean? Well, means that, oh, and we could have, yeah, we could have, this is going to have green in it. Whoops. This is going to have green in it because, wait. It's going to have the green 4-5 in it. And this is going to have the pink 4-5. This pink, not the other pink. Maybe I should change that color now that I'm using. Maybe I'll. Yeah, I don't know. I don't know. I was just thinking over here. Was there some way, like, can we force this to be this pink or this 8-9? And I don't see that that's the case. This again is gonna have. Wait, this is a. This digit here. This 8-9 is gonna be across here, which is gonna make this purple. This coloring is getting out of hand. I think, so this is going to have, these are going to be 4-5-8-9s. And these are going to be 4-5-7s. Oh, I don't know if you could hear my neck just, that was a loud pop. Yeah, I wish I was using like one less pair of colors. Let's see. This has the yellow 8-9 in it. This is... Well, what do these two add up to? This adds up to either 12 or 14, which is the same as these. Yeah. It's either 12 plus 3 or 14 plus 1. Okay. Yeah, all the ones with the 1s and 3s are going to be like this. So that means I can get rid of one of these coloring systems, because light blue will always go with this. So dark blue and hot pink. How do I want to get rid of this coloring? There's so much coloring. Okay, let's just start fresh. This will be dark blue. So these have to be light blue. These have to be dark blue. This has to be light blue. Okay. Now the 4-5 that goes with light blue will be light green. So one of these will be light green. This will be light green. The 4-5 that goes with dark blue will be dark green, which puts a dark green there and a light green. Yeah, that puts a light green here. Now the 8-9 that goes with dark blue will be dark pink, which means one of these is dark pink, one of these is dark pink. Wait, yeah, one of these is... I might have that wrong. Let me think about that. This must be dark pink. Yeah, so these are good. It's going to be switched in the middle box. Yeah, this is this and this and this are light pink, which puts light pink in those. And this must have light pink in here and light pink and dark green. This must have dark pink and light green. And this needs a dark green. This needs light green and dark pink. Whoops, and dark pink. Okay, I'm glad I reset the colors there, because that was getting a little wild. So this must be dark pink and dark green. And this must be light pink and light green. Okay, so this one can't be a 4 or 5, because it sees the opposite 4-5s. And this can't be 8 or 9. So this must be the light pink, and this must be light green. This can't be light green then, because it sees light green here. So this can't be dark pink anymore. Let's see. Oh, this light pink, this can't be light pink anymore. So this can't be 8 or 9. So this is 8 or 9 and can't be dark green. Okay, what's left in this column? This is 1, 2, 8, 9, and it has dark pink. What about this? This is 2, 3, 8, 9 with dark pink. So what about here? Oh, this can't be a 1. I guess I can remove them. So what about here? We need dark green here still. And we need dark blue. Though one of these could be dark blue. If dark blue is 1, it could be down there. It seemed really promising there for a moment, and now I feel like I've fallen behind. Or, I don't know, fallen behind. Fallen back from where I was. So we know the dark trio sums up to 15. Well, I guess both trios, either all three darks or all three lights, sum up to 15 because that's what's needed along with the 6 and 7 in the box. Yeah, this 7, which I don't even remember exactly how I got that. Oh, this 6 forced 6 over here, which forced this to be 3, 7, which put a 7 there, yeah. Is putting the 4, 5 here, which is nice, which let us resolve a little bit up here and down here. Whereas everywhere else, we have a lot of just this or that options. Oh, no, we don't. Here we go. This is an 8 or a 9. This can't be dark pink. Okay. So this can't be an 8 or 9. This can't be a 4 or 5. Now this can't be an 8 or a 9. Okay, good. I was a little worried. But I'm cruising now. This must be a 7 then, and it's not dark green. This can't be a 7 and is dark green. Where can we rule stuff out? This is a dark green. This can't be dark green. So this must be dark green. Okay, right here we have a pair, and it's a 5. Wait, really? Oh, it's just a... Wait. Oh, it's a 4... Wait. Did I mess up the puzzle? Oh no, not at this point. What do I need in the... Oh, okay, I see what I did. Whew. Panic there. It was literally the last thing I did. I numbered this wrong. I took off 4, 5 when it has to be 4, 5. Oh my gosh. This is a 4, 5, 8, 9. Oh my gosh, this is such a great puzzle, and I thought I had, last it all up there for a moment. Yeah, I wrote 8, 9 there, and then saw 8, 9. Well, this must be 4, 5, but then there has to be a 4 or 5 here. Okay, but I did see something else. This is this 27 diagonal. If this is an 8 or a 9, it's going to be dark pink, which will, even if these were 8, even if we minimize that, 8 plus 8 plus 9 is 25. This can't be a 2. So this can't be dark pink, which means this is dark pink, and this can't be dark pink. Dark pink looks down here, removes it as an option there. This is now a 7, this is now a 6 because of this 6. This is a 7 now because of that 7. This 7 is now a 7 here. Whoops, what am I doing? Okay, there we go. This 6 puts a, whoops, no, puts a 6 there. This light, oh, this can't be light pink, sorry, 1 second. This light pink comes over here. Can't be 8 or 9. This can't be 4 or 5. All what's left in the box is 1, 2, 3. This can't be a 1, this can't be a 3 because of those. I feel like there's a little bit more that I can do. Oh yeah, here's light pink. This, or sorry, light green. This can't be light green. So this can't be 8 or 9. And this one looks over here, so this is not 8 or 9. This is 8 or 9. Okay, what's left is we need a dark green in this cage. So this must be 4, 5. So this must be 2 or 3 because it can't be a 1. Okay, now I think we can. Well, yeah, I think we can resolve this all now, or almost all now. This 27 clue is going to be exactly what we just talked about, but kind of symmetric to what we did. So if we make these 8, I can just type it in. If we make this 8 and this 9, this is 2, and that resolves. If we make this 9 and this 8, that's 26, and this can't be a 1. So 9 pink, light pink is 9 does not work. So light pink is 8. Light pink is 8, and then dark pink is 9, which is then going to give us all of the colors. So 9 goes with 5, 1. So let's get the 5s going here first. 5s, and then we need a 1. Oh, let's do light green. I really like the color, the light green color. Just, apropos of nothing. Oh, what? Oh, no, that's 3. Sorry. It's the dark. I literally just said the dark colors are 159. And then, of course, the very first thing I do is fill them in wrong. So these 1s are dark blue. This 3 and this 3 are light blue. Okay. Now we just need to finish off the last bits of the puzzle. This is 2, 3. This 2 sees here. This is dark blue. This is light blue. Oh, this 7 here, I could have done that a while ago, I think, but it didn't affect anything. This is light blue 3, so this is a 2. I guess it's not really, that didn't force that to be a 2, that just was a 2 already. That's a 5. This is, which is a dark green. Yeah, dark green. This can't be dark green anymore, so this is light pink, which must be an 8. This is not light pink, so this can't be 8 or 9, and it's a dark green, so it's a 5. What's left here is light green 4. This is light pink 8. This is, oh my gosh, what is it? 2. Oh, what? Okay, the timer didn't stop, so I was a little worried. Okay, there we go. That was great. In the first, 5 minutes of that, I did not think I was going to get that puzzle done. And even once I spotted the, I don't know what to call it, set theory, sort of, counting up of the killer cages, even after I did that, I didn't think I was going to get it. But yeah, that was a tough puzzle. I think that was probably like at least a 3 out of 5. Because that was tough, but I feel like I made good progress on it and spotted what I was supposed to see fairly quickly, even though it was pretty tough. But yeah, that was a great puzzle. Thank you, Myxo. I'm not sorry. I don't know how to pronounce your name. Fortunately, internet names are not necessarily made to be pronounced. In the same way that, you know, given names are normally made to be pronounced. Anyway, thank you for that puzzle. That was great. I really enjoyed that. And thank you guys for watching.